Hello. This video is going to be about finding inputs and outputs given the graph of a function. So what you see in front of you is a video of Desmos. So it's a embedded browser window. And so what I'm going to do is walk through this Desmos example to see how we can not only use Desmos effectively, but also use this as an opportunity to talk about graphs in general. So you could imagine this as two things. This would be a graph on a piece of paper where we don't have Desmos and you have to find information from it. But also I'm going to show you some of the Desmos functionality. All right, so suppose we have our function f of x is negative x plus 6. Now if I plug this into Desmos, it's going to give me the graph, which is the red line. So all of the points on this graph are input-output pair. So what it's telling me is along my x-axis is my inputs and along my y-axis are my outputs. So every time I have some sort of input, say at 5, so here I would have an input of 5, what I'm going to do is consider what's the output. So if I plug 5 into my function, if I come over here and I put 5 in as my input, what should happen is I should get negative 5 plus 6, which is 1. And so what I do is I come up here and I put a point at input of 5. The output should be 1. Now every single point on this line obeys that rule. So they're all input-output pairs. So with that in mind, some typical questions that we might see would be something like this. I might ask you to evaluate the function at a particular value. So this down here, so this notation, we know that f is the name of our function and this is representing our input. So I want to know what is the output of this function, f, when I have an input of 5. So if I wanted to do this analytically, is the word that we use. So if I want to do this analytically, what I would do is I would take my function. Right, so if we come up here, our function is this, negative x plus 6. So I could say this is negative. Instead of x, I have a 5 plus 6. And the output, if I have negative 5 and I add 6 to it, I get a 1. Okay, so I know that the answer to this question is 1. The output of my function when I plug in 5 is 1. But how do we see that on a graph? So if I wanted to do it graphically, what could I do? So what I'm going to do first is I'm going to draw in this green line at x equals 5. So what this green line represents is what are all of the possible y values when I have an input of 5. And so what I'm going to do is I'm going to look at this green line and I'm going to ask myself, where does it meet the red line? Where does it meet the graph of my function? Now if I use Desmos, we can see that it actually highlighted a point for us here, and that point is 5, 1. So this ordered pair, 5, 1, tells me if I have an input of 5, my output should be 1. Okay, and if we don't have Desmos, what we can do is once I have that point, once I find that point there, now I'm going to draw in a horizontal line, this blue line, and I just ask myself, well, where does that meet the y-axis? So if I think about this, I'm asking myself, if I have an input of 5, then the y-coordinate that corresponds to that is going to be 1. And so that's how we get this ordered pair, 5, 1. Now, if we do have Desmos, a fast way to do this would just be to ask Desmos this. Right, so I'm gonna plug in f of 5. So just like the notation that we have down below, f of 5. So I have this notation down below. This f of 5 is the same as this f of 5. And down here I got an output of 1, and Desmos also tells me that my output should be 1. Okay. So let's pause for a second. You can pause the video if you'd like, and we're going to think about this f of 2. So I'm going to be quiet here for a few seconds. All right. So now let's work through this example f of 2. So what I'm going to do is, on this Desmos worksheet, is I'm going to just change this n to be a 2. And so what I want to do is I'm going to find 2, and I'm going to draw in this vertical line. And the question I have is, okay, if I look at this vertical line, when x is equal to 2, I'm going to come up here, and I'm going to figure out where does it meet the graph, and I'm going to look over. And I want to know what that point is. So let's go ahead and draw in this horizontal line. And my question is, if I have an input of 2, what is that point over there? And so if we just choose that point on our graph, it tells us it's 4. So if I have an input of 2, I should have an output of 4. And we see that point 2, 4 is in fact on our graph. All right, so now that I know what I'm expecting to have an output of 4. Let's come down here and let's look at f of 2 and see if we can do this analytically. Well, my function is, I should have negative 2, so that's negative of my input, plus 6. So negative 2 plus 6 is 4, which is exactly what I was expecting. So an input of 2 corresponds to an output of 4, and that means that point 2, 4 is on my graph. Okay. So this is a very common thing that we're going to see. If I have a function, I'm going to tell you what it is, and I'm going to ask you to evaluate the function at a particular point, and that's the process that we just went through. Well, if we go back and think about our function, well, I might not always give you the input. I might ask you a question. I might ask you a question that looks something like this. Solve f of x equals 5. And so what you're doing here, what you're doing when you solve f of x equals 5, is I'm asking you, what is the input I need to get an output of 5? So let's say that again. When I asked you to solve f of x equals 5, I'm asking you, how do I get an output of 5? What is the input that corresponds to an output of 5? So what we're going to do is we're going to go up here, and outputs are on my y-axis. So I'm going to type in y equals 5. And I'm going to look at this line. So I want to know, instead of starting with my input, I'm going to start with my output and work backwards. So when do I get an output of 5? So I come over here and I look at all of the y's that have a 5, and I find the one that's on my graph. And it turns out that if I want to have an output of 5, I need to have an input of 1. So I come over here, I look at my graph, I have this 1, 5. So what I should expect is, if I have an input of 1, then I should have an output of 5. All right, so this is what the graph told us. So let's come down here and let's see if we can do this analytically. Now, if you recall, that function, we had this definition. F of x equals negative x plus 6. So my question is, when is this thing equal to 5? So putting these two pieces together, I get negative x plus 6. Okay, so that's my f of x. And then I want to know, when is that equal to 5? Bring that down. Okay. So now I just need to get the x by itself. So step 1, I'm going to subtract 6 from both sides. And positive 6 minus 6 is 0, so I just have minus x over here on the left. 5 minus 6 is negative 1. Okay, well, I want to undo my negative signs, so what I'm going to do is I'm going to multiply by negative 1 on the left, and then I'm going to multiply by negative 1 over here on the right. Negative times the negative is a positive, so this tells me x equals 1. So analytically, I see that if I want to get an output of 5, it has to come from an input of 1. And then if I go back up here to the graph of my function, I also see that. And so I can do this and say, well, if I put in this line y equals 5, I just figure out where does it meet my graph, and it turns out that that input has to be a 1. All right, see you next time.